Hi girls, today we are going to see the topic about memory addressing capacity and CPU. What is called memory addressing capacity means it denotes the number of bits that a CPU can process at one time. Modern processors, including embedded systems, usually have a word size of 8, 16, 24, 32 or 64 bits. Most currently general purpose computers use 32 or 64 bits nowadays. In my previous classes, I explained about the evolution of microprocessor. On the topic, I explained about the processor, the microprocessor, 4-bit microprocessor, and then 8-bit, 16-bit microprocessor. So these are all the evolutions of the processor. Memory addressing capacity means how many number of wires, how many number of channels carries bits is called the memory addressing capacity. This allows one memory address to be efficiently stored in one word. Okay. Next, the memory capacity is calculated by using the 2 power n into m. N means address bit. N address bits equal to 2 power n addresses. M means data bits. M is the width of the data path. Width means how many bits it can carry. The values of typical values of n can be 16, 17, 18, 22, etc. M can be 8, 16, 32 and 64. This is the concept of the memory addressing capacity and CPU. Let's A is equal to number of address wire and D is equal to number of data wires. Data means what the data carry to one port to other port is called the data. The wire that carries the data means it's data wires. Address wire means from which address port the data carries is called the address wires. A is equal to number of address wires and D is equal to number of data wires. That is, A is the width of the address bus, D is the width of the data bus. Width means number of bits to be carried. In many older computers, the address bus was 16 bits wide. 16 bits wide, A is equal to 16. This means that there are 16 wires. Such microprocessor could address up to 2 power 16. Usually these are all in the 2 powers only. Such microprocessor could address up to 2 power 16 means 65,536 memory locations. If the memory addressing capacity of the CPU was 16, the processor could address up to 2 power 16, that is 65,536 memory locations. Okay. So by increasing the width of the address bus, the memory locations can be directly addressed. Each time the width is increased by one wire, the addressing capacity is doubled up by doubled up. ARM processor normally have 32-bit wide address buses. If the address bus the width of the address bus is 32, that is 2 power 32. A 32-bit ARM processor could address up to 2 power 32 means 4 crore something, the 4294 you can see in this number. This numbers of memory locations are available. So the width of the address bus doubled the width of the address bus is the width of the address bus determine the memory addressing capacity of the CPU. In older computers, the data bus was a mere 8 bits wide. Data bit means the data carries at a time is 8 bits. Each location was an 8-bit byte. Each byte could store either an unsigned number in the range 0 to 255 or 2's complement signed number in the range -128 to 127. By increasing the number of data wires by 1, the capacity goes up by 2 power a bits. ARM processor have 32-bit wide data buses, each location in a word which is 4 bytes or 32 bits long. Each word could store either a signed number in the range 0 to 42949679295 numbers or 2's complement sign number in the range. Okay. The total address capacity is in the bytes 2 power a. For an ARM processor, the addressable capacity is 2 power 32 bytes. Normally, the memory addressing capacity was determined by both the A and D. A means the address bus, address wires, and D means the data wires. By this, the number of wires in the address bus determining the addressing capacity of the CPU, and the number of wires in the data wires determines the number of data to be carried between the two ports. Here you can see the difference between the word size and the address size. Word size is the characteristics given to the computer architecture. It denotes the number of bits that the CPU can process at one time. Word size is a characteristic given to computer architecture. It denotes the number of bits that the CPU can process at one time. Modern processors, including embedded systems, usually have the word size of 8, 16, 24, 32, or 64 bits. Most current general purpose computers used nowadays are 32 or 64 bits. Okay. Very often, when referring to the word size of the modern computer, one is also describing the size of the address space on the computer. Size of the address space on that computer. For instance, a computer said to be 32-bit also usually allows a 32-bit memory addresses. A byte addressable 32-bit computer can address 2 power 32. For example, you can hear the word this computer has a 32-bit processor. That means the memory addressing capacity of that CPU is 32-bit. That means 2 power 32 is equal to 4299672 bytes of memory can it handle, or it's simply called as 4 gigabits. 2 power 32 is equal to 4 gigabits of memory. Okay, so you can see this how the bytes and gigabits are calculated here. So you people keep it in mind that the memory addressing capacity of a CPU was determined by the processor's memory address. For example, today's most of the systems have the memory addressing as 32 or 64. So what is the use of that 32-bit means if a processor has a capacity of 32-bit, it has the memory addressing capacity of 32-bit. That means 2 power 32-bit is equivalent to the 4 gigabits. So this allows one memory address to be efficiently stored in one word. Okay. Computers can have memory address larger or smaller than their word size. For instance, many 8-bit microprocessors such as MS technology 6502 supported 6-bit address bus. Because the word size is different from address size, so if the word size is smaller than the memory address also. Here you can see a computer can have a memory address larger. Memory address is larger than the word size. For example, 8-bit microprocessors such as MS technology 6502 supported 16-bit address. If not, they would be limited to EMERA 256 bytes of memory addressing. The 16-bit Intel 8088 and Intel 8086 supported 20-bit addressing via segmentation. How these are capable means an 8-bit microprocessor, but it supports a 16-bit address. He doubles the wire. In the internal ports. Like that, 16-bit Intel 8088 support 20-bit addressing via segmentation, allowing them to access 1 megabit rather than 16 kilobits of memory. And Intel processors such as Pentium Pro include physical address extension PAE, which supports mapping 36-bit physical address to 32-bit virtual addresses. Many earlier processors held 2 address per word, such as 36-bit processors. In theory, modern byte addressable 64-bit computers can address 2 power 64 bytes. This means 16 exabytes, but in practice, the amount of memory is limited by the CPU. The memory controller or the printed circuit board design. Example, number of physical memory connections or amount of solder on the memory. So the number of bits Number of bits decides the number of addressing capacity. Here the difference between the word size and the address size is, word size denotes the number of bits that a microprocessor, that a CPU can process at a time. But the address means the addressing capacity, how the wires carries the data, that all those things are determined by the 2 powers. In this you can see this all are in the 2 powers. If the addressing bit is 16, it is in the 2 power 16. If it is 32, it is in the 2 power 32. Okay, thank you guys.